device like this is used for the control lines that run over a Mothra or a mesh type kite. Um, so you have, say, a large arch kite up here, and on those load path arch lines you have a line that adjusts either the foils, the vertical sort of gill parts that radiate to the center, um, or you have the back panels, the traditional lifting surfaces that keep the whole arch rigid and tall. If you have those controlled along the load paths they sit by this sort of arrangement whereby you have a collective controller and you can push it forward or backwards in this area. So you've got lines that would be set off on a winch here, set on a winch here, and then the other end run to the kite. Here you have basically a load balancing, a thrust vectoring point, really. So when you move this forward, it changes the balance of the lines over the arch. So pushing forward would maybe say change the thrust vector so that the kite stands tall, pulling back, it drops back to the side, brings out the panels pointing left or right. Yeah, pointing the back of the panels pointing to the left, the whole thing pulls right if you pull right. Left if you pull left. I might have got that backwards. But yeah, the idea. The panels would have a force multiplier on here. It would be a tough pull. You know you can't use this for load pass. This is for the control panels only, control lines. But I reckon you can get quite a lot of control out of something like that, simplifying the work of a kite. You know, this could be set in a sort of a domed or a circular thing to more represent the kite shape itself, to get the flow of the gearing right. Yeah. Apply this to the boat model of a steerable mesh kite, like a steerable Mothra, and this was sat in the middle of the kayak, say. These bottom lines controlling, say, the back left, back right, front left, front right, steering and pitching on the underneath kite. Remember, a twinned arch system where you've got the huge air kite, then you've got the very small water kite. If you can control the thrusting and the vectoring in the top one to, say, point off, drag you down that way, and the C one is going to drag you up this way, the overall vector thrust is shooting forward that way. So if you're balancing a couple of kites against each other and you want to keep the trim sort of relative, yeah, possibly you'd want it like this. I think you'd probably want separate for the upper and lower, but mirroring them would be good. Yeah, maybe have that top. I don't know though, depending on the current flow and how that is relative to the wind. I think this could be good for a twinned arch system.